Hi everyone, and welcome to a new episode in the Multiverse video series. I'm Javier Luraski, and today we're going to learn how to use barrier execution in Spark using R. So in order to understand what barrier execution is, we first need to do a quick recap of what distributed R is in Apache Spark. Now, I'm not sure that we have a video about distributed R, but you can read about it on the Mastering Spark with R book. And I'm going to give you a quick refresher of what exactly is distributed processing. So there's a lot of ways of using Apache Spark, and a lot of the functionality is already available for you. For instance, you can use DBI, or you can use dplyr, or you can use machine learning functions or feature transformers to get mostly all the stuff that you need in the day-to-day done. However, there might be cases where you want to use your Spark cluster and you have to specify custom transformations using R code. Using Apache Spark and R together. So, we can take a look at a very specific example. So for instance, suppose that we have a data set with the numbers 1, 2, and 3, and suppose that we want to multiply them by 3 using R code. And the function that we're applying is pretty simple, it's 10 times the number, and we should get that output. And here is an example on how to do that. So actually, first of all, we need to connect, and we need to do all the things that we are already familiar with. All right, and now that we're connected, almost connected, what we want to do is basically create this transformation. And before we do the transformation, let's take a look at this. SDF len of 3 should give us a data frame with 3 elements, 1 to 3. And what we can do is now we can apply our transformation just as we were looking at in that diagram, which is simply multiplying by 10. Now, the interesting thing here is that we're actually using R code to perform this transformation. So this is left for very advanced use cases, and it's not something that you want to do in your day-to-day. If you wanted to do this, what you want to do actually would be something like dplyr, transmute, and then you can do something like id equals an id times 10. So this should work, and this is much more efficient than distributing R code in your entire cluster. But there's a few use cases where this makes sense, and we're gonna see another one of those today. All right, so what we're doing here is applying R code to transform these using a custom transformation, which is multiplying elements by 10. Now, this is all great, but there's a problem in some use cases. Now, as you can see here, when we specify what are we transforming, Spark decides how these partitions are gonna get transformed. So we don't need to worry when using Spark where this particular data set lives, or this particular partition. Like number 10 could live on one computer, number 20 and 30 could be a partition in a separate computer, and Spark is smart enough to perform that transformation. Now, this is actually great in most advanced use cases. You specify a transformation, and Spark can do the distribution of the task for you. However, there is one case where this execution model kind of breaks, and we're going to take a quick look at one of those use cases. So the case that I want to mention, without getting into too many details, is suppose that you want to use Spark to perform modeling using TensorFlow or PyTorch or any other advanced library out there, which is usually requires to give access to the particular nodes in the cluster, and then the library communicates with the nodes directly. Older technologies might use things like OpenMP, and why not? But the bottom line is that there's cases where some of the libraries that are out there actually require the libraries to communicate with each other directly by using an IP address or a machine name. And that's exactly how TensorFlow distributed works. Like, you need to specify in TensorFlow which are your machines that are part of that cluster. You join them together by creating this cluster specification, and then you ask TensorFlow to use those machines in a distributed fashion. So how we would do that with Spark Apply? So the problem here is that we're specifying a custom transformation, which in this case is 10 times x, but we have no control whatsoever of where this is getting executed, right? So we don't have a way of controlling that. And this is the problem that barrier execution is trying to solve. So great talk that you can use to understand this is one from Spark Summit from Reynold, where he introduces barrier execution under this project called Hydrogen. And I believe Hydrogen is mostly just the code name of the project, and the actual name of the feature is barrier execution. And kind of like what he explains here is that most of our workflows, what you can see on the left side is most of our workflows are custom workflows, like the one that we just kind of like we're looking at. They're basically mappings where Spark can control where the task is being executed. And that's the whole point of Spark. It's a high-level framework that abstracts a lot of the internals of cluster computing to you, such that you can focus on doing data analysis modeling without the burden of figuring out where things are executing. However, there's cases like, for instance, when doing training for deep learning in TensorFlow and PyTorch, where you actually need access to those particular nodes. The library needs to know where those nodes are located, and your particular cluster needs to make use of those nodes and send the data directly to each node. So for those cases, the concept that Spark introduces starting in Spark 2.4 is barrier execution. Now, I was so excited about this particular feature that actually is being contributed by Samuel Macedo that I decided to make a video. So this feature is not yet available on Sparkly R. It's actually being developed, but it's likely that by the time you watch this video, the feature might already be merged in master, or if you're lucky, it might already be on Spark 1.1. So the way this works is as follows. So there's a new parameter in Spark Apply, and what this parameter does, it basically specifies that you want to execute some code in barrier execution mode. And what this means is that instead of just executing an arbitrary command in any of the machines without you having to worry about anything, instead what Spark is going to do is it's going to take that particular partition that is already available and is going to make sure that you get allocated all those resources at exactly the same time. So in this case, we're requesting only one resource, but and we're going to get only one resource, but we could also potentially request 2 or more or 100, and Spark is going to make sure that we get those resources allocated for us. And so if we were to execute this, basically the same thing should happen, although it didn't in this case. Yes, so this didn't work out because I've modified the code that I was showing, but we could basically, the original data set is numeric, right? So we want to keep the same data type, which is actually not that one. It's probably a double because we didn't force it to be. So let's try that. Is it double or is that maybe an integer, right? So you need to specify the correct data type, which is an integer for the operation to complete, right? So we have the right data type, we have the transformation. So how is this different than the previous execution mode? Well, what this execution mode adds is it adds also one more parameter. And if you're not familiar with this syntax, basically this means the first parameter of your Lambda function. But we can also be explicit and say the first parameter is my data frame or my partition, and my second parameter that barrier introduces is the actual barrier, the barrier context actually. So let's convert this to a character and see what's inside. And now we want to actually specify this as a character. Yes. Yeah, this looks about right. And what we see here is that what we're getting instead for this particular context is we're getting the location that is available for us in this cluster to make use of this executor. Now, this is not a very interesting example because everything is running locally. But if we were using a real cluster, what we would see here is different machines with different host names that we can use to connect. So we can also use kind of like a different repartition here and just kind of like see what happens when we're working locally. But as you can see is that we're getting, in this case, 2 machines we are running locally, right? Because we basically have multiple executors running this particular machine. And as you can see, we get different addresses. So actually what would be more useful, I believe, would be just to get the address directly from the barrier context, which SparklyR provides for us, which would give us just the host names where this particular model, that we could use to execute particular models. Right, so I know that this doesn't sound super interesting, perhaps, because it's a pretty advanced feature, but what is really interesting that what you could do now, and I leave this to be presented in a different video, is what we could potentially do now. Let's clean this up. What we could potentially do now would be something like library TensorFlow, and then we could potentially do something like TF, and whatever library we need to specify here, and define the cluster, I guess called cluster spec or whatever. This is just pseudocode; it's not going to work until we get the correct actual parameters. But what you could do here would be to initialize a TensorFlow cluster using Spark. Now, this would work because mostly we're specifying the cluster specification as part of running barrier execution. We get the machines that Reynold was mentioning in this particular slide. So we would get like the entire set of machines when we're doing barrier execution with Spark apply. And, then we can use these to do, model training on TensorFlow, or why not? So again, this is a pretty new feature that is being developed at the moment. I was kind of like too excited not to do a video and share kind of like where this is going. I'm definitely planning to do one more video later on showing how you can actually get TensorFlow and Spark working together. But that's probably going to take a little bit longer. All right, well, I hope that you enjoyed this video. It's not our standard video. Definitely, it's kind of like more future looking and something to be excited in the next few months. But I still hope that you found it useful, and we'll see you later.